Hey guys, welcome back. It's day 12. Some of the 7th graders, you guys missed the lesson, so I hope you listen through this video and fill out your notes. You should have the notes for 12A. Okay, so today in class we talked about interpreting inequality word problems. To write an inequality from a word problem, you should follow the following steps. First, you got to figure out what you don't know. Represent it with a variable. So this is just like when we're solving equations and we're doing word problems, we use that let statement. So I want you to identify the variable with the let statement. Figure out what you do know, and number 3, is there more than one possible solution? 4 is very important. What type of inequality symbol is needed? And then number 5, at the end, make sure your answer makes sense. Okay, so here we have some keywords that you should look at. So if we have the word above 7, above would be just greater than. Okay, it wouldn't include the equal sign. But if it's at least 7, it would include the equal sign. At most 7, it would be less than or equal to 7. And you can go through this whole example, look at the keywords with examples. Okay, let's look at the example we have here. Write an inequality to represent the following situation. Debbie has at most, so that's going to be important, at most $60 to spend on clothes. She wants to buy a pair of jeans for $22 and spend the rest on t-shirts. Each t-shirt costs $8. Okay, so what don't we know? We don't know how many t-shirts can be bought. So let's let X, so our let statement is let X be the number of shirts. Number of shirts. Okay, let's do this a little neater. Okay, so we're going to let X be the number of shirts. Okay, the inequality, because it's $8 per shirt, is 8x plus $22 for jeans. And at most means it has to be less than or equal to 60. So we have the inequality there. Now if we solve it, we subtract our 22 from both sides. We get 8x is less than or equal to 38. And then when we divide both sides by 8, we find out that x is less than or equal to 4.75. Well, we can't buy 4.75 shirts, so do we want to round up or round down? In this case, we're going to round down because if we went up to 5, we would be spending too much money. So the answer here would be 4 shirts. Okay. All right, so let's try some. Paul's age is 10 years less than 5 times Ken's age. So if I look at this, 5 times Ken's age, it's 10 years less than 5 times Ken's age. Well, we don't know what Ken's age is. We don't know what Paul's age is, but we can write Paul's age relative to Ken's age. So our let statement is going to be let K be Ken's age. Okay, and if K is Ken's age, then Paul's age is going to be 10 years less than, there's that keyword than, so 5 times Ken's age minus 10. So we have 2 expressions. If the sum of their ages, so we're going to add their ages, so we're going to take Ken's age and we're going to add Paul's age, and it's greater than or equal to, so there's our greater than or equal to 26. Okay, so there's our inequality. Now I'm going to combine our like terms, 6k minus 10 greater than or equal to 26, and then I'll add my 10 to both sides. 6k will be greater than 36. Okay, and then when we divide by 6, k is going to be greater than or equal to 6. So we're finding the youngest possible age for each boy. So in this case, we know Ken's going to be greater than or equal to 6. So the youngest age that Ken could be is 6. And then when we plug in 5 times 6, we get 30 minus 10 is 20. We find out Paul is 20 years. So Ken is 6 years and Paul is 20. All right, moving on. Mrs. Stevens had a certain amount of money in the bank. Okay, do we know the amount of money? No, that's an unknown. After she deposited means we're adding $350. She had at least $1,170 in the bank. So what is the smallest amount of money Mrs. Stevens had in the bank before her latest deposit? So if we let M be equal to money, we're going to take the money and we're going to add $350 and we're going to get at least 1,170. So that would be greater than or equal to 1,170. Okay, so there's our inequality. And then we subtract 350 from both sides. Our money is going to be greater than or equal to 820. So the smallest amount would have to be $820. Okay, moving on to number 3. Mary decided she would not spend more than $275 for a new coat and dress if the price of the coat was $15 less than 3 times the price of the dress. So $15 less than 3 times the price of the dress. So that's the coat. Okay, what was the highest possible price of the dress? Well, we don't know how much the coat is, we don't know how much the dress is, but we do know that the coat can be defined in terms of the dress. So let's let D be equal to the dress. If D is the dress, then the coat expression could be equal to $15 less than 3 times the price of the dress. So 3 times the dress minus 15. There's our two expressions. Okay, if the highest possible price. Now, if we're buying them together, we're going to buy our dress, and then we're going to buy our coat. Okay, and we don't want to spend more than $275, so it's going to have to be less than or equal to $275. All right, now to solve it, we've got our 4D after we combine our like terms. Okay, we're going to add 15 to both sides. So we get 4D is going to be less than or equal to 290. We then divide by 4, and our D is going to be less than or equal to $72.50. Okay, so the highest possible price of the dress would have to be $72.50. All right, a movie theater sells adult and child tickets. If at one showing last week 200 more adult tickets were shown than children's tickets, what is the smallest number of each type of ticket that was sold if the total number of tickets sold was at least 500? Okay, so in this case, 200 more adult tickets were sold than children's tickets. So we don't know how many children's tickets were sold, so let's let C equal children's tickets. Okay, and if C is children's tickets, then our adult ticket would actually be C plus 200 because it's going to be 200 more. Okay, if we take the children's ticket and then we add the adult tickets, okay, at least 500 is going to have to be greater than or equal to 500. So that would be at least 500. We then combine our like terms, and then we subtract our 200. So 2C is going to be greater than or equal to 300. Okay, so now when we divide by 2, whoops, where did my screen go? Okay, now we're going to divide by 2, and our C is going to be greater than or equal to 150. So we can say that we have 150 children's tickets. Okay, because we're looking for the smallest amount. The smallest amount would have to be 150. We add, I don't know why that keeps happening. We add the 200, so 150 plus 200, let's do it up here. C is 150. We add 200, and we get 350 adult tickets. Okay, so 350 adult. Okay, number 5, the length of a rectangle is 10 inches less than 2 times its width. Okay, our let statement, we don't know what the width is, so let's let the width be W. We can write the length relative to the width by saying it's 10 inches less than 2 times. So 2 times the width minus 10 would be the expression. So because it's got 10 inches less than, sorry. If the perimeter, okay, let's draw a picture. The perimeter of a rectangle is less than 160 inches. So if these sides represent the width and the sides here represent the length, the perimeter is going to be 2 times the length plus 2 times the width, or we can just add up all the sides. And that's going to be less than 160. Okay, when we combine our like terms, we get 6W minus 20 is going to be less than 160. we add our 20 to both sides. 6W is going to be less than 180. So when we divide by 6, our W is going to be less than 30. So since it's just less than, the maximum width of the rectangle can't be 30 because it's got to be less than 30. So we're going to have to say something like 29.99999. It's kind of a weird question. Okay, inches. Okay. All right, now the last one that we're doing right now, Susan received grades of 86, 90, 95, 92, and 98 in 5 math tests. What is the lowest grade that Susan can score on the 6 tests in order for her average to be greater than 92? So the way that averages work is you take all of your scores, you add them together, okay, plus 92, plus 98, plus our unknown. So let's let G be the grade, okay, because we don't know what that missing grade is. So we're going to add it in, and then we're going to divide by 1, 2, 3, 4, 5, 6, okay, and that's going to be greater than 92. All right, I add them all up, and I get 461 plus my G divided by 6 is, whoops, it's going to be greater than 92. All right, now to get rid of my fraction, I'm just going to multiply both sides by 6. Okay, and when I do that, these will cancel out. Okay, so this is going to be 461 plus G is going to be greater than 552. Okay, because I multiplied this side by 6 as well. Now I subtract my 461 from both sides, and when I do that, G is going to be greater than 91. So we want it to be greater than. It doesn't say greater than or equal to 92, so a score of 91 would get her to 92, so let's just say it's going to be 91.1 or anything higher, so it could be a 92, okay? So that's a little vague of an answer, but as long as it's greater than 91, okay? All right, so give the homework a try, and good luck. Bye-bye.